On January 30th, a SpaceX Falcon 9 rocket successfully launched a Northrop Cygnus cargo spacecraft to the International Space Station, ISS, from Cape Canaveral Space Force Station in Florida. This marked the first time that Cygnus was launched aboard a Falcon 9, as previous missions primarily utilized Northrop Grumman's Antares rocket. The Falcon 9 lifted off from Space Launch Complex 40 and deployed the Cygnus cargo spacecraft into orbit about 15 minutes later. Following the launch, the Falcon 9's first stage returned for a successful landing at Cape Canaveral, completing its 10th flight. Northrop had secured 3 Falcon 9 launches for Cygnus, while concurrently collaborating with Firefly Aerospace on the development of Antares 330. This new version of the rocket, slated for launches starting in mid-2025, replaces the Ukrainian-built first stage and Russian-manufactured engines with components produced by Firefly. Northrop indicated that minimal changes were made to the Cygnus spacecraft and its processing flow to accommodate the switch to the Falcon 9. SpaceX, during a briefing on January 26, mentioned modifying the Falcon 9 payload fairing to include a door, facilitating late cargo loading just before launch. The Cygnus spacecraft, named SS Patricia Patty Hilliard Robertson, after the late NASA astronaut, arrived at the ISS and will be berthed by the Canadarm2 robotic arm on early February 1. It is scheduled to remain at the station for at least 100 days. Loaded with 3,726 kilograms of cargo for the ISS, the Cygnus payload includes crew supplies, scientific investigations, and vehicle hardware. The research payloads encompass a range of topics, from biological research to demonstrations of a surgical robot system inside the station, and robotic arms developed by Jitai outside the station. As part of the cargo, NG-20 includes a variety of fresh food items for the ISS crew, such as hazelnut spread, hummus, and plenty of ice cream. Astronomers have made a groundbreaking discovery by identifying previously unseen stars, including a new category of elderly giants humorously referred to as old smokers. These mysterious celestial objects, situated at the core of our Milky Way galaxy, have the ability to remain inconspicuous for extended periods before suddenly emitting clouds of smoke, as revealed in a recent study published in the monthly notices of the Royal Astronomical Society. Led by Professor Philip Lucas from the University of Hertfordshire, an international team of scientists monitored nearly 1 billion stars in infrared light during a decade-long survey of the night sky. This effort resulted in the identification of dozens of rarely observed newborn stars, known as protostars, undergoing intense outbursts during the formation of new solar systems. These protostars, often concealed by dust and gas in visible light, became visible through infrared detection. Utilizing the Visible and Infrared Survey Telescope, VISTA, located at the Cerro Pinal Observatory in the Chilean Andes, the researchers focused on 222 stars displaying significant changes in brightness. Among these, they discovered 32 erupting protostars, exhibiting brightness increases ranging from 40-fold to over 300-fold. The ongoing eruptions allowed scientists to analyze these events at various stages of evolution. Unexpectedly, the study also identified 21 red stars near the Milky Way center with ambiguous brightness changes. Professor Lucas proposed 3 potential explanations: protostars beginning an eruption, recovering newborn stars, or older giant stars emitting matter akin to old smokers. Further analysis confirmed that these stars represented a new category of red giant stars, characterized by a dim and red appearance lasting several years. These aging giant stars are concentrated in the nuclear disk, the innermost part of the Milky Way rich in heavy elements. The researchers noted that the mechanism leading to the observed ejections of dense smoke remains a mystery. The findings challenge existing understanding of element distribution in space, suggesting that matter ejected from these elderly stars may play a crucial role in forming subsequent generations of stars and planets. Professor Dante Menitti from Andrés Bello University, Chile, and founder of the VVV survey, emphasized the unexpected nature of these discoveries, describing how these elderly stars remain dormant for extended periods before unexpectedly releasing clouds of smoke. The implications of this newfound stellar phenomenon may extend beyond our galaxy, potentially influencing the distribution of heavy elements in other metal-rich regions of the universe. in the arid landscapes surrounded by desert mountains and clear blue skies in northern Chile, astronomers from the Vera C. Rubin Observatory are set to transform the field of astrophysics. Their ambitious project involves attaching the world's largest digital camera, equivalent in size to a small car and weighing 2.8 metric tons, to a telescope. Funded by the US, this $800 million camera is expected to capture unprecedented views of the cosmos, with the aim of initiating a 10-year survey called the Legacy Survey of Space and Time, LSST, starting in early 2025, situated 2,500 meters, 8,200 feet, above sea level on the Cerro Pacun Mountain, 560 kilometers, 350 miles, north of Santiago. The observatory is managed by the U.S. Research Center StarLab. Stuart Corder, the deputy director of StarLab, anticipates that this endeavor will bring about a paradigm shift in astronomy. The facility contributes to Chile's already dominant role in astronomical observation, hosting a third of the world's most powerful telescopes and benefiting from exceptionally clear skies. The Rubin Observatory's camera, boasting a staggering 3,200 megapixel capacity, will capture images so expansive that it would take over 300 average-sized high-definition televisions lined up together to display just one photo. Built in California, it surpasses the current most powerful camera, the 870 megapixel Hyper Prime in Japan, by threefold and exceeds StarLab's most potent camera by sixfold. The LSST aims to provide a comprehensive survey of the sky, offering insights into 20 million galaxies, 17 billion stars, and 6 million space objects. This initiative will contribute to an updated inventory of the solar system, enable detailed mapping of the Milky Way, and facilitate deeper investigations into energy and dark matter. Chile's significance in astronomy has evolved from humble beginnings, exemplified by the 40-centimeter Cerro Tololo telescope transported on a mule in the 1960s. The country now hosts several world-class observatories, with the Vera C. Rubin Observatory joining the ranks. The region's unique desert landscape, nestled between the Pacific Ocean and the Andes, ensures optimal observing conditions due to minimal cloud cover and a dry climate. The observatories in northern Chile, including the ALMA Observatory and the upcoming extremely large telescope, attract astronomers from over 30 countries. The area has been the site of numerous groundbreaking discoveries, such as the 2011 Nobel Prize-winning revelation about cosmic acceleration, reinforcing Chile's position as the astronomy capital of the world, according to Bruno Diaz, president of the Chilean Society of Astronomy, SOCIAS. NASA has announced the crew for SpaceX's Crew 9 mission to the International Space Station, ISS, set to launch no earlier than August. The quartet includes cosmonaut Alexander Gorbunov from the Russian space agency Roscosmos, along with 3 NASA astronauts, Zina Cardman, Nick Hague, and Stephanie Wilson. Zina Cardman will command the mission, with Nick Hague serving as the pilot, and Stephanie Wilson and Alexander Gorbunov as mission specialists. The launch is scheduled to take place atop a SpaceX Falcon 9 rocket from Florida's Space Coast in August. Though a specific date has not been finalized, both Zina Cardman and Alexander Gorbunov will be making their first spaceflight, having been selected by their respective space agencies in 2017 and 2018. Nick Hague brings experience from 2 previous space missions, including a 2019 trip to the ISS, which followed an aborted launch due to a rocket problem in 2018. Stephanie Wilson, with a total of 42 days in space across 3 orbital missions, joins the Crew 9 mission, having previously flown aboard the Space Shuttle Discovery. Crew 9 marks the 9th operational astronaut mission to the ISS for NASA, utilizing SpaceX's Falcon 9 rocket and Dragon capsule. The mission will briefly overlap with Crew 8, with its launch scheduled for no earlier than February 22. A team of scientists, led by researchers from the Massachusetts Institute of Technology, has discovered 12 supermassive black holes that are consuming stars, emitting infrared light in the process. This research indicates that events where stars are torn apart, known as tidal disruption events, TDEs, are more common across various types of galaxies than previously observed. Typically, astronomers have identified TDEs through bursts of visible light or intense X-rays. However, this team used infrared light for detection, which is advantageous as it can penetrate galactic dust clouds that might obstruct visible light and X-rays. The study, published in the Astrophysical Journal on January 29, reveals that TDEs occur more widely in different types of galaxies than previously thought. Infrared light becomes crucial for astronomers as it allows them to observe TDEs that may not be visible in optical bands. Megan Masterson, the lead author and MIT graduate student, explained that to comprehend TDEs as a whole and study supermassive black hole demographics, looking in the infrared band is essential. Prior to this research, most TDEs were found in post-starburst galaxies, which go through a period of intense star formation before becoming quiet. However, these starburst events tend to clear away galactic dust, leading astronomers to question whether such events naturally cause more TDEs or if dustier star-forming galaxies are simply harder to detect. Searching for TDEs in infrared light provides an alternative to optical and X-ray surveys. When a black hole tears apart a star, the resulting TDEs generate infrared light, and the surrounding galaxy dust also heats up, emitting detectable infrared radiation. The team made their first infrared TDE detection in 2023, using archived observations from NASA's NEOWISE mission, originally designed to search for asteroids and comets. Through an algorithm, they identified 18 TDE candidates based on a temporary surge in infrared light. After finding evidence that 6 of these candidates involved galaxies actively feeding on material from a pre-existing disk around the black hole, not a single star, the researchers confirmed 12 infrared-only TDEs. This discovery challenges the notion that TDEs only occur in post-starburst galaxies, showing that they happen in various galaxy types. The findings align observations more closely with predictions regarding how often supermassive black holes consume stars in any given galaxy. While previous optical and X-ray surveys indicated rates lower than expected, the new observations of infrared TDEs suggest a rate closer to predictions. Astronomers aspire to use TDEs as tools to measure the fundamental properties of supermassive black holes, which is currently impossible to achieve directly. Enhancing understanding of the entire population of TDEs through infrared observations is a step toward achieving this goal. StarLab Space, a collaboration between Voyager Space and Airbus Space and Defense, has chosen SpaceX's Starship to launch its commercial space station, StarLab. The agreement, announced on January 31, did not disclose specific terms or a launch date. StarLab Space expressed confidence in launching before the planned decommissioning of the International Space Station in 2030. Dylan Taylor, chairman and CEO of Voyager Space, praised SpaceX's track record of success and reliability, citing their high-cadence launches. StarLab will be launched in a single flight using SpaceX's Starship, a decision influenced by the latter's capability to handle the size of the station. The joint venture between Voyager and Airbus was finalized on January 9, after they announced their collaboration in the previous August. Voyager had previously partnered with Airbus, ending a previous association with Lockheed Martin. StarLab is designed as a large habitation and laboratory module with an attached service module for power and propulsion. Its size, with a diameter exceeding 8 meters, makes Starship the most suitable launch vehicle, as other existing or under development vehicles cannot accommodate its dimensions. Both StarLab and Starship are constructed using stainless steel, taking advantage of large launch vehicles capable of placing up to 100 tons into low Earth orbit. The module will be manufactured in a shipyard and fully integrated on the ground, reducing manufacturing time to 3 years and cutting launch costs by more than 80%. Despite the advantages, collaborating with SpaceX poses challenges as it is a potential competitor. SpaceX received an unfunded NASA Space Act agreement in June, as part of the Collaborations for Commercial Space Capabilities (2) initiative, studying the use of Starship as a commercial space station. The collaboration with SpaceX aligns with StarLab's goal of demonstrating a single launch solution, showcasing the evolving landscape of commercial space. Tom Ochinero, Senior Vice President of Commercial Business at SpaceX, expressed excitement for Starship to launch StarLab, supporting humanity's continued presence in low Earth orbit and contributing to the vision of making life multiplanetary.